So in this video then, we're going to go through a question on electrophilic addition. So I'm not going to go through lots of questions on this because you will find that when you cover electrophilic addition, it's always the same. And people will always come to me and say that they struggle with mechanisms, they find mechanisms difficult. That's fine, but I will always say to them that these mechanisms don't change. Okay, especially A level. Okay, what you learn at A level is very much a straightforward approach. Okay, it's electrolytic addition always works the same way. Every mechanism always proceeds in the same way. So with that being said, I'm going to go through quite possibly I'm going to say the trickiest question you could get at AS level and probably A level too, based solely on electrophilic addition and nothing else. So I'm not linking other topics in here because that can obviously complicate things, but just electrophilic addition. So it's a straightforward mechanism that you use predominantly with alkenes. Okay, it's adding a compound across that double bond. Again, the clue's in the name. Okay, if it's electrophilic addition, then it's an addition reaction. So you're not going to get a second product. You're going to get one product, whatever you're going to add the two things together to make one other thing. There's no additional products there. There's no substitutions going on. The clue's in the name. And if you really do struggle with mechanisms, you can just, learn the arrows. I know it sounds like a terrible way to do things. I'd much rather people understand what's going on. But if you can't, I'd much rather you just learn the arrows. So this is going to be what I'm going to go through now. So they give you compound A, and they are going to add hydrogen bromide. So compound A reacts with hydrogen bromide, so let's put it here, plus HBr. And it forms a mixture of two different organic products. Nice and straightforward. Give the structure of the two organic products, outline the mechanism for the formation of one of the organic products from compound A, explain which of the two is more likely to form. So lots of stuff to be going on with here. It's worth 6 marks. It's a 6-mark question, so it's quite in depth. Notice you only need to draw one mechanism for this. So I'll draw both, but for the purpose of the question, you only need to draw one. And to be fair, you'll see in a minute what I mean by this. It doesn't really matter what you do, but it's going to be the same thing regardless. So first things first then, let's draw our compound. Let's draw it all out again so I can actually get it on the board. So here we go. So we've got ourselves a rather straightforward molecule. Okay, so it's really, really easy. It's not a complicated alkene at all. We're adding HBr, and this is where we need to consider what's going to happen here. So the first step in electrophilic addition is always going to be the same. And this is why I say it's easily learned. If if you're good at memory, it's easily learned. We're reacting with HBr, so I'll put the HBr down here. Now, first thing to remember about HBr is that it does have a dipole. It is polar, and therefore Br is going to be more electronegative. So delta minus, delta plus. Okay, those charges are important, so make sure you put them on. Now, the first arrow of the mechanism, people always get messed up by these arrows. So just a reminder then, arrows, the curly arrow, okay, the brilliant curly arrow, it shows the movement of a pair of electrons. So a pair of electrons start here and they finish where the arrow is. So that means the arrow has to start where the electrons are, always. Okay, it's almost like source to sink. Okay, the electrons are at the beginning of the arrow every time without fail. Okay, which means if you ever draw an arrow starting from a positive charge, you've done it wrong. So for example, let's do it wrong just to show you. So let's say I want to say, well, I know that the hydrogen has to bond to the carbon, so I'm going to draw an arrow from here to the carbon. Haha, brilliant. No, that's absolute nonsense, because where are the electrons? We've got a delta positive hydrogen. Where are the electrons coming from? Oh yeah, they're not coming from anywhere. So even if you like I say, you can just learn this. If you don't want to, that's fine. But from a purely theoretical standpoint, you cannot draw an arrow if there are no electrons to draw it from. So don't draw it from a positive charge, please, for the love of God. Okay, if ever you do that, if you do that in an exam by mistake, just give yourself a smack on the head and then erase it and then do something better, because it's never going to be right, ever. Now, where are the electrons in this system then? Well, believe it or not, they're in this brilliant, fantastic double bond. There are 2 bonds here, 4 electrons are just sat there doing nothing. So we're going to start by taking this bond and breaking it. And this negatively, well, this region of electron density, it's not going to be negative. Don't think that they're always going to be negative. Okay, and there's going to be a big sign saying here are the electrons. Okay, double bond, 4 electrons instead of 2. That's electron density in my opinion. There's plenty of electrons there to go around. So we start from here, draw the arrow from the bond to the hydrogen. Okay, the curviness, it needs to be curved. Don't just draw it straight. It has to have some sort of curve to it. Okay, they're not going to measure the angle of the curve, but it has to be somewhat curved. Start from the center of the bond. Do not start from the carbons. The electrons are not on the carbons, they are in the bond. Okay, I'm just going to extend that bond to make it more clear. Okay, start from the bond. That's where you have to start from. Again, if you don't do that, examiners will dock you a mark. So, it's not me being pedantic, it's me telling you what the examiners are going to do to you. Now, the second thing that happens is the hydrogen is attached to the carbon, and that means that this bond here is going to break. The one in the center between the hydrogen and bromine will break. I'll just extend this a bit as well so we can see it a bit better. That will break, and the electrons will go heterolytically onto bromine. Okay, so hydrogen doesn't need the electrons because it's going to go and bond off the carbon. So we start from the center of this bond where the electrons are, and we put those electrons onto bromine. Now, this is where, so that's the first step, and if you're interested, this is always the first step in electrophilic addition. The arrows will always do this. From the door bond to the hydrogen, or whatever the positive charge is, break this bond onto the other thing. Always. Never changes, memorize it. Now, the question then becomes, what happens next? Because there are 2 competing reactions going on here. So I'm going to draw 2 arrows. Okay, because the question becomes, where does the hydrogen bond? It can either bond to the carbon on the left or the carbon on the right. So we need to draw both eventualities here. Notice the double bond now breaks. We've broken that double bond. Okay, now remember, you only have to draw one of these mechanisms. I'm drawing both to highlight, highlight the 2 products so you know what's happening. You don't have to draw both. You'd only have to draw one in the exam. But for completeness, I'm just going to put both in. So we'll put the hydrogen there. So the hydrogen can either bond on the left hand side, as in there, or it can bond on the right hand side, as in there. So let's just put in the rest of this, CH3, and then just put in our other CH3 and our H there. I don't like how I've drawn that. I've drawn that badly. I don't like that. Yeah, when you draw these intermediates, just draw them as you would normally. Yeah, I don't like how I've drawn that at all. Yeah, so there we go. It looks a bit neater now. So there we go. There's 2 options. H either goes on the left or the right. Does it make a difference? Absolutely, because the molecule isn't symmetrical. Okay, you've got 2 CH3s on the right hand side and 1 on the left. So these are 2 different products with 2 different names. And of course, I'm missing something important here, a positive charge. Okay, the carbon is missing a bond, it's positively charged. Okay, you don't need to put the charge in circles, I'm just doing it to highlight where they are. And the only other thing we're missing now is the bromine, because the Br is now floating around. It's gained a pair of electrons, so bromine is now floating around with a lone pair of electrons, and it's negatively charged. Okay, I would put both on. Okay, put the lone pair on and put the negative charge on. That way you do not leave yourself open for missing a mark. And then we do the final step of the mechanism. Okay, funny thing is about these mechanisms. Okay, this mechanism only has 3 arrows. Okay, we've already done 2 of them. Okay, this one and this one, always the same. And the third arrow is always the same as well. We need to draw an arrow linking the bromine to this carbon because the bromine is going to attach. How, you ask? Well, hopefully you can see very clearly how it's going to work. Okay, electron pairs are clearly on the bromine. Okay, this is the lone pair, negative charge. Now there is a big sign saying here are the electrons basically. And you're going to draw an arrow from the negative charge to the positive one. Okay, or to the carbon, either or, doesn't matter. Okay, now you can draw, now this is what I'm going to do 2 versions. You can draw your arrow from the negative charge or the lone pair. okay, has to come from one or the other. Okay, must come from one or the other. Okay, you cannot draw it from the bottom, for example. If I just draw one in red that's wrong, for example, just to highlight. If I draw my arrow from here, okay, that's wrong. Okay, if I draw it from here, that's also wrong. Okay, must come from the negative charge or the lone pair. That's where the electrons are. Yes, examiners will penalize you for it. So I'll just leave those in red to highlight incorrect versions. And the outshot of this is, of course, you get two products where you get the bromine attached here and then the bromine attached to the side. And that's the mechanism. That's it. That's all it is. There's no differences. Okay, every question will be a play on this same theme. Okay, they'll use different compounds, maybe different molecules. Does not matter. It's the same thing every single time. Okay, and I've drawn both mechanisms here just for fun. Okay, it's very easy to draw both actually. I'd rather do both than just one because it easily shows you what's going on. So there you go. That's a very badly drawn finishing product. And that's it. That's most of the marks. The only thing we've missed is explaining which of the two products are likely to be formed. And we can do this very, very quickly. It all comes down to this intermediate here in the middle. Okay, the middle part. The positive charge on the carbon is obviously unstable. Now, the most common product is going to be the one with the more stable positive charge. And that is going to be the one that has the most carbon atoms coming off of the positive charge. So by that I mean this carbon in the center. Let's do a quick highlight here. This carbon, oh wow, that did not work at all, did it? That's a rubber. What am I doing? So this carbon in the center, if I can actually use this thing properly, I meant to click on the highlighter and I didn't. This carbon in the center, there you go, fancy that, is bonded to 1, 2, 3 other carbons. This carbon is bonded to 1, 2. Now, the more stable positive charge is the one bonded to the most carbons. So this is the more likely to form. So this will be, so this mechanism on the top is the likely product because it follows the more stable intermediate. So major product with this one, and there'll still be some of this one made, but it's a minor product. And all you got to do, essentially, is to explain this in words, because there are lines to explain this on underneath. Okay, you need to say that the intermediate, so this over this one at the top. Okay, here, intermediate has the more stable carbocation. Okay, it's the tertiary carbocation. Oh my God, Ti. Are you kidding me? Te. Oh, I can't spell. Why did I say it was Ti? Tertiary. Tertiary is better than secondary. That's all you need to write. Okay, that's everything you need to get that last mark. So there you go. This gets you 6 marks. Okay, obviously I've drawn both mechanisms. You don't need both mechanisms, but either way, I've just done it as an illustrative purpose. And all you need to write as an extra is the intermediate has the most stable carbocation. You can say tertiary is better than secondary. And that's it. That's all you need to say. No more explanation needed. It's just about the stability of the carbocation, and you want the major and minor products. So that's it. Electrolytic addition is dead easy. Okay, once you get the hang of it, it's really straightforward. So my advice is, if you're struggling with it, it is one of those things you can just repeat it ad nauseum. You can just do look, cover, write, check over and over and over again until you're bored of it. And that's the whole point of chemistry, by the way, is to get so bored of it, because you're that good at it that you go and your exams are easy and it's just a waste of your time. That's the position you want to be in. You want to be bored by the subject in the end because you want to be that good at it. It's just a chore rather than something to be challenging. In terms of the mechanism, the arrows never change. So focus on picking out these 3 arrows, remembering what order they go in if you do struggle to figure it out, and then go with that every time and you won't go wrong.